all the three experiments, right? The CC cipher encryption technique and affine cipher and one-time padding. All these three of the experiments are belongs to the experiment number 1A, 1B, 1C. Out of that, the two practicals are the two experiments which are CC cipher as well as affine cipher technique, which were implemented practically with the help of the C language, with the help of the code block software, right? And also I given you the task in order to complete as well as implement the one time padding. I hope you have completed. By end of the practical, I'll be sharing the separate link for that. Through the link you can upload the coding as well as snapshot or the program write-ups which you prepared, as well as based on the implementation of the 1C, which is one time padding experiment in today's practical. And we will be studying as well as implementing the public key cryptography technique, one of the, I could say that one of the important public key cryptography technique, which is RSA algorithm. For that I'll this part, the theoretical explanation which is not covered in the lecture so far, so I'll take the quick review of the topics of public key cryptography, and then we'll move on to the actual content, right, which I'll be explaining as well as we'll be implementing practically. I hope the screen is visible and I'm audible clearly. If you face any difficulties with my audio as well as sharing the screen, and you can kindly write in the chat box. So I assume that my screen is visible and my voice is audible clearly. Okay, thank you for your responses. First of all, so far we were talking about, we were discussing about all the part of CC cipher encryption technique, polyalphabetic cipher, as well as one-time padding, and no DES and other techniques. Yesterday we discussed about different block cipher modes of operation. All those technique which are belongs to the symmetric key encryption only. When we talk about symmetric key encryption, the same key, the key which we are using for encryption, the same key which is going to be used for encryption as well as decryption will use only one key, right? The problem with this symmetric key encryption technique, if the sender is using the key for encryption, the same key which has to be shared to the receiver in order to perform the decryption, right? Now the problem is that whenever if the user is trying to share the key, there are chances that the security of the key can be compromised. Once if any attacker got the key which is used for encryption, and henceforth the attacker will have the complete information what is being conveyed through the network. So that, so to avoid that, to avoid sharing of the keys or avoid the repetition of the single keys, right, in order to solve or overcome the issues of sharing the key with the two users, right, now we'll have the other solution which is called a public key cryptography, right? When we talk about this public key cryptography, right, so this is completely different from the symmetric key cryptography. This public key cryptography can also called asymmetric cryptography. When we talk about the asymmetric cryptography, there will be a two different keys, right? Out of these two different keys, the key one which will be used for encryption technique, and then the second key or the key 2 which will be used for decryption process, right? So if there are two users in a communication, they wanted to securely exchange the message, right? User A and user B, right? They will have a pair of keys. Both the users, they will have the pair of keys. One second. Right? If there are two users, I hope the open board screen is visible. Anyone can quickly acknowledge in the chat box. I just opened the open board screen, right? I shared with you. If there are two users, they wanted to exchange a message using a public key cryptography, user A and B. So both the users, they will have a pair of keys. Out of that, one key will be called as a private key, and the second key which will be called as a public key, right? When we talk about this private key, which is P K, and public key which is represented PU, right? PK which is notated as PK, and public key which is represented as public, I mean PU, right? So if the users as the two keys, here the user will have private key of A and then public key of A, and similarly user B will have private key of B and then public key of B. I hope this is clear. If there are two users, they wanted to share a secret information with the help of the public key cryptography. When you talk about the public key cryptography, I was explaining about whoever present or whoever wanted to share the information using a public key cryptography, those users will have a pair of key. One key will be called as a private key and the second key will be called as a public key. Now, out of these two keys available with the all the users, right? One key will be kept private, and the remaining key, and that means the public key, which can be shared with the other users in the network. So, for example, the public key of user B. So, this can be shared with the user A. Similarly, the public key of A user will be shared to the user B. Very similarly, if there are n users, say for example, user 1, user 2, user 3, user 4, and user 5, and the public key of 1, which will be shared with the all the users. So public key of A will known by all the users, user 2, 3, 4, 5. Very similarly, the public key of B, public key of 3, right? So public key of 3 which can be shared with all other users who are present in the network. So this means that every user's public key will be known to all other users who are going to use or who are going to involve in a communication. I hope this is clear. When we talk about the public key, the public key of one user which can be exchanged or shared with the other users publicly. When it comes to the private key is secret key, which is confidential one, which is very secret. At any cost, user will not share the private key to others, right? I could explain simply this example, the two keys example with, now I can correlate with the email IDs. When you wanted to get a mail from other users, what you will do, that you will share your mail ID, right? So in that cases, your mail ID will be your public. So with the help of this public, with the help of the mail ID, anyone can send a mail. But When it comes for the private key, which is similar to your password, you will not share, or you are never supposed to share the password with the others, right? And with the help of the password, your own password, so that is with the help of your private key as per this scenario. So with the help of the private key, only the authorized users or authenticated users, you can read the mail. I hope you are all getting the point what I'm explaining, what is this public key as well as private key. If you have any queries regarding this, what is the public key as well as private key, quickly can write in the chat box. Then if there are no more further queries, then I can proceed furtherly. Is there any query? So I'm getting the positive acknowledgement from Alia, Abid. What about others? There are 25, including me. Are you all clear with this, the basics of public key cryptography, or you want me to explain it again? So one thing you're supposed to remember is that when we talk about a public key cryptography, one uses public key which can be shared with the other users, right? If anyone wanted to contact or send a message to the any other users with the help of the public key, they can send a message, right? So private key is more confidential. At any cost, user will not share the private key, right? So out of these two keys, one will be used for private and the other one will be used as a public key, right? With this, I'll continue with my presentation slide. I can explain further. Now, this is a simple scenario through which how the public key cryptography can be implemented in order for a secure message exchange, right? So this is our actual information, which is plain text, right? So that is going to be encrypted with the help of an RSA algorithm, which is we'll be discussing in further, right? Which is a one public key cryptography technique, right? For that, see here, I could delete this part. Here, this is the two users. Here, this is an Bob. User Bob is a sender, right? So here the receiver is Alice, right? So here you can see the ring of the Bob's public key ring. So he has a keys, a public keys of Joy, Mike, Alice, and Ted, right? So suppose if the Bob wants to send a public key encrypted message to the Alice, right? So Bob is the sender and Alice is the receiver. If the Bob wants to send a message to the Alice, now Bob needs to encrypt the data using the receiver's public key. Now who is the receiver? Alice is the receiver. Now he will search, he will find out the Alice public key and he will do the encryption using RSA algorithm with the receiver's public key. Here the receiver is Alice. So I hope this is clear. The sender will do the encryption. In order to do the encryption, and he will use the public key of receiver. Here the public key of the receiver is Alice, right? So here the encryption part or encryption is carried out by using the receiver's public key. Now you will obtain the cipher text which are going to be transmitted through the network to the receiver. While if the Alice is receiving the encrypted message, right, and the data which is received, which is a cipher text, now the cipher text which has to be decrypted only with the help of the private key of receiver. I hope this is clear. One thing you're supposed to keep in your mind is that whenever if you are using one user's public key, the key in order to use for the decryption is, right, the same once public key is used for encryption. In that cases, here the allies public key is used for encryption and alias private key which will be used for decryption, because both the keys are related to each other, right? The alias private key as well as public key are related to each other, right? So I hope this is clear again, right? Now this this type of encryption, right, using the receivers, here I've used both the credentials, public key as well as private key of the receiver. So if any kind of encryption, public key encryption technique which uses receiver's credentials for encryption and decryption, so this technique which provides confidentiality or secrecy. Any guess how it provide confidentiality or secrecy? Any idea or guess? Faisal, how can it achieve confidentiality? Anushka, what is confidentiality and secrecy? We discuss in the very first second lectures. When we talk about CIA triangle, confidentiality, integrity, and availability, confidentiality, I elaborated more on confidentiality. When we talk about confidentiality, is a security. Other than the intended receiver, no other person should not be able to read the message or read the information which is being conveyed. How this achieve the confidentiality means, here the key which is used for decryption is the receiver's secret key. Who will know the receiver's secret key? Because it is only known by the receiver. This is not a public key, it is a private key of the receiver, right? The person who knows the private key, only he can able to decrypt the message. That means that it provides 100% sure that only the receiver can decrypt the message. I'll explain the same with the email scenario, right? Suppose if I'm sending an email to you, right, with your public key is your mail ID. Through this I can send a message, but who will decrypt the message, who will read the message? The person who knows the password for this mail ID, say for example abc at the rate of gmail.com, right? To this mail I sent a mail, and the person who knows the password, who know the password, only the receiver know the password, only he could read the message by entering the right password. By the way, this mail has been achieved confidentiality or secrecy by proving that it has been read by only the intended or actual user. I hope this is clear. By the way, if you are using receiver credential for encryption and decryption, so that technique which intents or which provides confidentiality, right? The other scenario, when we use the sender's credential, say for example if the Bob is here, so now Bob uses his own private key, right? Forget about this diagram, right? Otherwise I can take a fresh page in the open board, I can share it. Suppose user A wanted to send a message to the receiver B. Now in order to do the encryption, the sender will use its own private key of A or PKA, PRA, whatever it is, private key of A, right? Now, after doing an encryption, you will get the cipher text. The cipher text which is going to be delivered to the receiver. Now, receiver want to decrypt the message. Now, in order to do the decryption, What key will be used by the receiver? Any guess? I am explaining a scenario. In this technique, the user senders credential are going to be used. Private key of whom? Anushka, your answer is correct. Private key of whom? Wrong. Yes. Uzain, your answer is wrong, but I appreciate that your response, but your private key of the sender. No, Anushka, how can a private key of the sender आपका पासवर्ड दूसरा का शेयर करेगी कि आप अनुष्का थिंक इन सच ए वे दैट आपका ईमेल आईडी का पासवर्ड रिसीवर को शेयर करेगी या मैं आपको मेल भेज दिया मेरे पासवर्ड भी मैं आपको देता हूं आप लॉग इन करो मेल रीड करो ऐसा बोलेंगे क्या अनुष्का इज इट सो आर यू देयर अनुष्का okay you're thank you I got no ample of responses right it is to be understood that here whenever if the data is encrypted by the sender's private key and the same uses the second key which is alternate key which is public key of a here in order to do the decryption public key of a will be used how the receiver will come to know the public key of a how will come to know because it is the public key of one user which can be shared with the all other users which I explained in prior right so by the way one user's public key will be known to all other users right so this technique whenever if you are using sender's private key for encryption and sender's public key for decryption so this technique which provides authentication. What is meant by an authentication? Anyone can unmute and say the answer, which we discussed in the very first or second lecture during CIA. Also explained
Um,
about, yes,
Authentication to identify the identity of the sender.
yes, in order to
Uh,
verify whether the person who is sending the message, who is accessing the device, whether he is an authenticated user, right? How we will identify whether the person is an authenticated user? Suppose if I am the user, if I wanted to open my Gmail ID, the person who is entering the right Gmail ID, right password, and he will be an authenticated users to use or read the messages. Very similarly, in order to access the devices, in order to open your devices, you may need to enter the correct no the username as well as password login name, right? Any laptop or mobile, in case of mobile, and you need to use the you need to give the correct pin numbers in order to open the mobile, as well as the person who is entering the right pin number to withdraw the money from the ATM, and he will be considered as an authenticated to use the particular resource, right? So by the way, this also can be called as a digital signatures. If any data or any information which has been encrypted using sender's private key, right? So this proves that the message is coming from an authenticated user, because in order to do the encryption, the sender uses own private key. So but the sender's private key will known only by the sender. So if he has encrypted the data with his own private key, that assures that the message is originated from the authenticated user A, because the message has been encrypted by sender's private key. But obviously, it shows that the message is coming from the user A, right? The decryption will be carried out using sender's public key. I hope this is clear, right? What we discussed so far, we discussed about what is public key cryptography, where we'll have the pair of keys, right? One is private key, which will be known only by the individual users, and the second one is public key. So this can be shared with all others, right? Then we discussed about confidentiality or secrecy. when you talk about confidentiality or secrecy, right? If receiver's credential used for encryption and decryption, encryption has to be carried out using receiver's public key of receiver, and then decryption is carried out using private key of receiver. And when we talk about an authentication, is the second technique through which, right? So here the data is going to be encrypted using sender's private key, and decryption has to be carried out using sender's public key. So this achieves authentications. Is there any query? Okay. So I hope this is clear. If you have any queries regarding the basics of public key cryptography, what is private key, public key, and what is confidentiality and authentication, you can raise your queries. So I'm happy to answer for your queries. I assume that this is very clear for you, right? With this, I'll move to the actual algorithm, which is RSA algorithm. Right? So this is an algorithm which was proposed by the three authors, Reversed, R and Shamir and Adelman. R, all the three authors first letter, which is RSA, so which formed RSA algorithm, right? This is an abbreviation for RSA. Basically, it is a public key cryptography which was introduced in the year of 1977. So this algorithm was proposed by three authors, Rivers, Samir, and Adelman. Okay. So now this will take maximum of 1024 bits, right? As well as, and it is going to work completely based on the prime numbers as well as prime factors, modulo, prime, all the prime related mathematical part which we discussed in the second half of the first one, where we discussed about number theory, right? We discussed about what is prime number, and we discussed about what is GCD, then we discussed about primitive root, right? So based on these concepts are this RSA algorithm which is going to work, right? So this is I'll start with the algorithm part, right? So first thing is that users, if there are two users, right, they wanted to send a message, right? They need to select two keys. One is a private key and the second one is public key, right? So this RSA algorithm, which is going to work based on the prime numbers, right? You all might be knowing about what is meant by the prime numbers. The first step is to select the prime numbers. Prime numbers, let's assume it is a P and Q. And after that, second step is that they need to find the modulus value, which is a multiplication of two prime numbers, P and Q, right? And after that, they need to find another value, which is pi of n, which is based on the P minus 1 and then the Q minus 1. Now, out of that, so now these two PQ are the prime numbers, not the key values, right? I'm explaining only from the sender point of view, right? Suppose if the user wanted to select a key, this can be a private key, any key, right? And whenever he is selecting a key, let's assume it is a private key. Sorry, it is a public key or private key, any key you can assume, right? This is, if I share, this is the public key, right? Now, based on the key, right, whatever the key which is selecting, right, the key, the value, the range of the key, right, that should be less than or greater than 1 and less than pi of n. and the GCD among E and pi of n should be 1. What is meant by this GCD, which is greatest common divisor? Greatest common divisor is the number, right, other than 1, right? These two numbers, whatever we are selecting, x and y, are E and pi of n. No other common factor should not be there between these two numbers except 1. So in that cases, we need to select are these two numbers. If the common factor is 1, if the GCD is 1, so these two numbers can be called as what? If there is only common number which is 1, in that cases these two numbers can be called as prime factors. No, relatively prime. Very good, Anushka. Relatively prime or co-prime, I would say that co-prime or relatively prime. These two are prime to each other. What is meant by prime number? When we talk about a prime number, there should not be any common factor rather one and by its own. Suppose if I am taking 7 and 7 ka factors should be 1 and the same number. By the way, it is called a prime number. But when you talk about the co-prime number, among these two numbers, whatever I am selecting, say for example 7 and 9. So these two are called a co-prime because there is no common divisor or common factor between these two values except 1. I hope this is clear, right? Now, and followed by that, we are going to do the encryption function. And in order to do the encryption, and we'll be using the formula which is ciphertext equal to, and at the same time we need to use the value which is m, which is a plain text. In order to do the ciphertext, what we are going to do is that we are going to use the formula ciphertext equal to m is the plain text, m power e mod n, right? So here these they have taken this e as the public key values, right? So here the public key parameters are e and n is the value which has been calculated from the two prime numbers. And when we talk about the decryption value, so after that this will produce a ciphertext will be shared with the receiver. By receiving this ciphertext, and he will be doing the decryption, right? So decryption to be carried out, I'll erase this complete part, right? Decryption will be, at the end of the decryption we'll get the plain text, right, which is here, let's assume, which is c is the ciphertext, c power d mod n. Now what is this d? Let's assume this is a private key. How this private key can be calculated? Again, how many of you understood? I can explain it further, don't worry. I'll be explaining one more time, right? So these are the credential which is through that we can generate this p comma q again, which is multiplication of p comma n, p comma q, which can be represented as n, right? I hope this is understood a little. I can move further with the whiteboard. Here I can explain further. So my first step is that select two prime numbers. Let's understood it is 17 comma 11 comma 17, right? The second thing is that this RSA algorithm, which is going to work based on the primal multiplications, which is modulo, so which is n is equal to P multiplied by Q, which is 11 into 17. What is the value of 11 into 17? Quick. Which is 187, correct? Make sure these two numbers are prime numbers, 11 and 17. Okay. And the third step is that we need to find the pi of n value, which is P minus 1 multiplied by Q minus 1, which is 10 into 16, which is 160. I hope the first three steps are clear. Now the fourth step is that, right, user need to select a public key. Say for example, we are doing it for the receivers, right? With the help of these values, right, now we are going to do some calculation. Say for example, if the user selects public key, which is E, what is the condition? E should be greater than 1 and less than pi of n value, right? And GCD between this E and pi of n should be 1. By the way, I can select any numbers, right? So let's assume I am selecting my E value is equal to 7, right? Now if I select my E value is equal to 7, GCD between 7 and pi of n value, which is 160, is equal to 1. Is this condition satisfied? GCD between this 7 and 160 is 1, right? Because 7 is not the factor of 160. I hope this condition is true. Correct? I'm taking little extra time so you will understand more clearly. So then you will understand, we will implement it through programmatically, right? So then my plain text, whatever the message which I wanted to send, let's assume my plain text value is equal to M, right? Which is, let's assume which I can take some 88 value, or you can take any random value, it doesn't matter. So for example, if I'm taking my value is equal to 10, right? After that, what are the values we have? We have plain text, and then we have the public key of the receiver, let's assume, right?